How's it going, world? In this video, we're going to be talking about 1-2 transformations. So if you want to write at the top of your notes, 1-2 transformations, that is what we're going to be doing in this section. But for this sake, essentially all we're going to be doing is kind of moving graphs around. So I'm just going to start typing a few graphs and kind of see what we see. You should all know this is your parent function for y equals x squared. So what a transformation is essentially just moving that parent function around. Up, down, left, right. We'll learn later that we can multiply and change different things. So again, there's your parent function. But say I wanted to move it in some direction. Say I add 1. Well, what happened? It moved up 1. So that would make it move up 1. Say I did minus 2. Well, that's minus 21. Minus 2. Well, from your parent graph, so from this graph, this moved down 2. So essentially that's what's happening. So I'll kind of show you how I think about this in just a minute. I'll write it down for you and show you more. But notice if it's on the outside, it moves up and down, so y equals x. I get to leave school. Yay! But that's really for lunch. I already ate lunch, though. Anyways, minus 2 makes it move down 2. Plus 3 would have made it move up 3, again, from the parent function. This works for any parent function as well. Say we're looking at our cubic function, so I change all these to cubes. That is not a cube. That is a cube. And make that a cube. So again, same sort of deal. Plus 3 still moves it up 3, so notice our green is up 3. Our blue is down 2. We had a minus 2. So now, the way we move this left and right is we can actually throw this in parentheses such that minus 1. Let me get rid of this one for a moment. So notice it says minus 1. Usually we would have thought that would have moved it down 1, but check this out. This is actually, it's inside kind of with the x. So if it's with the x, it's going to move in the x direction, so left or right. And notice it did the opposite of kind of what we think it would. Minus, we usually think of the negative direction, so we probably would have thought it would have gone to the left. But instead, this is moving to the right one. Well, if you guess, minus 3 would make it move to the right 3. So how do you think we would move it to the left? Well, we still need to throw it in parentheses. And if I want it to move to the left, I'm going to do the opposite of what I think. So if I want it to move the negative direction, I'm actually going to throw a plus with it, such that now this thing has moved to the left 3. So let me write this down for you guys, and let's actually talk about these things. All right, so I'm going to take a look at these 5 and just see what transformations we actually have to do here. So I've given you the parent function. So our parent function for this one is x squared. We know that's the parent because we have something squared. So now, as far as whether we move up, down, left, or right, what I say is if something is inside, that's what I call it, it is considered to be with the x. And it's inside the parentheses. So like here, this minus 2 is different from our parent function, and it's inside with the x, so I'm going to move left and right. And just like we just saw, if you're with the x, you're going to do the opposite of what you think. So usually we would think negative would go in the negative direction, but since it's with the x, just like when you break up with your ex and it's kind of weird and awkward, you don't really want to be in the same room as them, so you kind of go the opposite direction. So when you're with your ex, you want to do the opposite thing, you want to go the opposite direction usually. I mean, if you're cool friends, that's fine, whatever, yeah. But if we're inside with the x, we will do the opposite of what we think we will do. So instead of moving left 2, we will move our parent function to the right 2 units. Likewise, this is plus 1 inside the parentheses. It's a cubic, so that's our parent function because we see cubed just like we see cubed in our parent function. We see a plus 1 with the x, so instead of doing to the right one, we will move to the left one. All right. The other thing you could see, this one we know is our square root parent function because we're taking the square root of our variable. So now notice this plus 1 is considered to be outside is what I call it. Essentially, if it's not inside, it's outside. So I'm going to say this is outside because it's not under a square root with our x. It's not included. So this is going to move in the y direction, and we do exactly what we see, just like we saw. So this, we will move our parent function up 1 unit. This one, 2 to the x, it's not with the x, so it's outside, kind of with the y. So we will move everything down 4 units. Now we can do both things in the same equation. We can actually do more than this, but this is what we're exploring for now. So notice we have a plus 1 kind of inside with that x. This is an absolute value because we have the absolute value of x, the absolute value of our variable. So inside with the x, we have a plus 1, so let's do the opposite of what we see. So we will move to the left 1 unit, and then minus 2 is on the outside, so we will move everything down 2 units. So we'll kind of do that in that order. All right, so I'm going to take a look at a few graphs, and we're actually going to see what these will do. You guys will be able to graph these without a calculator. So this is where memorizing your parent functions is super important. All right, let's do it. All right, so let's say you are asked to graph this. First thing that I always do is I always graph my parent function. So I notice this is a quadratic because it is squared. So like I said, the first thing I will do is graph my parent function. And I kind of make it a dotted line because it's not actually the function that I want to see in the end. So I'm going through all the points, right? That is our quadratic parent function. Now this plus 2, again, it's with our x. So what that is going to do is it's going to move everything to the left too. Remember, when you're with your x, you're inside, do the opposite of what you think. So all I'm going to do is take every point I see. So my first point is 0, 0, and I'm going to move it left 2 units. So 1, 2, left 2 units. Move this point left 2 units. Move every point left 2 units, and graph the new function. That's it. So again, as long as you guys know your parent function, it's going to be super duper easy. All right, let's do another. All right, so again, we have x cubed minus 4. The first thing we need to do is determine what our parent function is. I see a cubic with my variable, so I know this is my cubic function. So I'll go ahead and graph my cubic parent function. Yeah, that was fast. You didn't even see me do it. All right, and then this minus 4, notice it is not inside with the x. It's not in the parentheses. There is no parentheses. So I consider this to be outside. So I'm going to move every point down 4. If it helps you right off to the side of what you're doing, so you don't have to go back and think every time. But we're going to take every point. We had one at -1, -1. So down 1, 2, 3, 4. You can move 0, 0, down 1, 2, 3, 4. 4 down. And we had a point at 2, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4. And I can graph my new equation best I can. Best I can, man. All right, and that's it. Let's do another. All right, so again, identify your parent function. This one is our exponential because we have our variable in our exponent. So I'm going to go ahead and graph our parent function. Cross it 1, and then 2, and then 4, and then 8. And it's going to get closer to our asymptote in that direction. So something like that. All right, now this minus 3, notice it's not really in parentheses, but it is all in the exponent. We would have seen something like that if it was not kind of like what we were looking at before in those other examples. We were just writing what happened. So this is with our x, so I'm going to do the opposite of what I think it's going to do. So I'm going to take all of my points and move them to the right 3. So 1, 2, 3. 1, 2, 3. 3. And I'm going to graph my new equation. All right, and that's it. That's really just something like that. Be able to give us the domain and range in set builder or interval notation, whatever we may ask for, just like we were talking about in the first section that we did. All right, and look at a couple more, and then you guys are done today. All right, so again, first thing, identify your parent function. What is it? I see my variable inside absolute value symbols, so I know this is my absolute value parent function, which looks something like this. Bam! All right, now, what is it doing? Well, we have a minus 3 inside with our x, so I'm going to do the opposite of what I think it will, so I'll move everything to the right 3. I have a minus 2 that is not with the x, so that means it's going to move in the y direction, so I'll move to the right 3 and down 2. So just take all of your points, move them right 1, 2, 3, down 2. Take this point, move it right 1, 2, 3, down 2. And it's going to do the same pattern that it was doing before. All of the points stayed in the same kind of relationship, but they've moved to the right 3 and down 2. Bam!
Oh, so pretty. Oh. Oh, yes.
All right, one more, and then you get to work on homework. All right, so our last one, again, identify the parent function. This one we have the square root of a variable, so this is our square root parent function, so I can go ahead and draw my square root on there. Now notice we have plus 1 inside with the x, so I will move to the left one. Remember, do the opposite of what you see. I have a plus 2 on the outside with my y, so I will move everything up 2. So take all of your points, move them left 1 up 2. So that's kind of like our new origin point. Left 1 up 2, left 1 up 2, and graph your new function. All right, that's really all I got for you guys today, short and sweet. As always, please, please, please come by, ask me questions. That's what I'm here for. That's what I want to do. I love you guys, and I will see you soon. I'm out. Bye-bye.